Okay, so this is the review for the first 6 weeks. I'm just going to go through each problem so that you can watch this and review and make sure you understand exactly what you're doing, since there are no retakes for this. Alright, so number 1, determine whether f of x equals 3x plus 2 times negative 6x minus 3 is linear or quadratic. And then after you do that, identify the quadratic, the linear, and the constant terms. So in order to determine if it's linear or quadratic, we need to FOIL and get it in standard form. So 3x times negative 6x is negative 18x squared. 3x times negative 3 is negative 9x. 2 times negative 6x is negative 12x. And 2 times negative 3 is negative 6. From here, I'm going to combine my terms. So it becomes negative 18x minus 21x minus 6. So because of this squared right here, this makes it quadratic. Okay, the quadratic term would be the term with the x squared. The linear term would be the term with the x. And the constant term would be the number by itself. Okay, so quadratic, squared, linear, just x, constant number. Alright, so there's the number 1. Okay, number 2, you're going to be using your calculator and you want to find the quadratic model. So basically, I want to find the equation that matches those points. So if you don't remember how to get to this, you're going to go to Stat, Edit, and I'm going to put these values in my list 1 and list 2. X values in list 1, Y values in list 2. So negative 2, 0, 4, 8, negative 4, 68. So there's my values. Okay, then I'm going to go back to Stat, over to Calc, and I want to do quadratic regression, so number 5, because it's a quadratic model. Okay, so there's my A, B, and C. I'm going to just take it and plug it in. So I have y equals 4x squared plus 2x minus 4 if I plug them in. Okay, so that's the first part. There's the quadratic model. Then it says predict the value, or the y value, when x is 7. So I'm going to take 7 and plug it in. So 4 times 7 squared plus 2 times 7 minus 4. So if we do that in the calculator, 4 times 7 squared plus 2 times 7 minus 4, I get 206. So when x is 7, y is 206. So both of these are your answers. Here's your quadratic model, here's your value, your y value when x is 7. Alright, number 3, write the equation of the parabola with the vertex 5, 3 containing the point negative 175 in vertex form. Vertex form is y equals a times x minus h squared plus k. Your vertex is always hk, so vertex is hk. That means this other point is going to be my x and y values. So I'm going to use those, plug them in, so that I can solve for a, and once I have a, I can plug it back in and get my equation. So if we start off, 75 equals, a I don't know because that's what I'm solving for, x is negative 1 minus h squared plus k. Okay, so we go here. Negative 1 minus 5 is negative 6. Negative 6 squared is 36. So this becomes 75 equals 36a plus 3. Okay, solve for a, I subtract 3, so I get 72 equals 36a. Divide by 36, so a is 2. So now my equation, if I plug it all back in this form, I'm going to have y equals 2x minus 5 squared plus 3. There's your vertex. Alright, on these factor, the main thing is, remember, you have to do GCF first always. So in some cases that might be all you have to do. On number 4, negative 15x squared minus 21x. Okay, well there's not a C term, so I'm not going to do my father drives a Mustang, so I'm going to look and see what they have in common. Negative 15 and negative 21 have negative 3 in common. X squared and x have x in common. So there's my GCF. So if I factor that out, I'm basically saying this times what gives me this. Or negative 15x squared divided by this results in 5x. And then plus 7. And you can check yourself by distributing. Negative 3x times 5x is negative 15x squared. Negative 3x times 7 is negative 21x. This is as far as I can go. I can't factor any further. And it doesn't ask you to solve, so you're done. Alright, on number 5. 3, 26, and 35, there is no GCF, so let's multiply A times C. 3 times 35 is 105. Two numbers that multiply to be 105 that add to be 26 are 21 and 5. If you don't know those, just go through your calculator and find numbers that multiply to be 20 or 105. Divide by A. Reduce. Put x on the bottom, read up, so this becomes x plus 7 and 3x plus 5. So there's your factors for that. And you're done. Okay, on 6. Is there a GCF with 18 and 32? The answer would be yes. It is 2. So this becomes 2 times 9x squared minus 16. Okay, and if you notice, 9 and 16 are perfect squares. So when they're perfect squares, this becomes the square root of 9 is 3. Square root of 16 is 4. So I'm going to have 3x plus 4 and 3x minus 4. And again, you still have to have that GCF out front. So there's your answer. Alright, number 7 is solve by factoring. So we're going to do what we did before, but then we have to take it one step further and solve. So first let's look. 3, 18, and 81 all have a 3 in common. So I'm going to take out a 3. And this is what is left. Okay, then if we factor here, factors of negative 27 that add to be 6. 9 and 3. 3 should be negative. Divide by A. So this becomes 3x plus 9 and x minus 3. Okay, now when we solve, we have to set each factor equal to 0. I can't set 3 equal to 0 because there is no variable to solve for. So x plus 9 equals 0 results in x equals negative 9. And x minus 3 equals 0 results in x equals 3. So there are my solutions. Alright, so same thing here. We need to make it equal 0, so I would subtract 3. So I get 10x squared plus 13x minus 3 equals 0. Okay, there's no GCF between 10, 13, and 3, so I'm going to leave it like this. Multiply A times C. 10 times negative 3 is negative 30. Factors of negative 30 that add to 13, 15, and negative 2. Divide by A. Reduce. Okay, so then put x on the bottom and read up. So I have, whoa, that's a fancy looking 2. 2x plus 3 and 5x minus 1. And again, we need to set them equal to 0. So this one equal to 0, I would subtract 3 and divide by 2. Other way around. Sorry. 3 divided by 2, so negative 3 halves. And this one, I would add 1 divided by 5. So there are my 2 zeros. Alright. Number 9. Solve by finding square roots. So in this case, if we moved the 147 over, I'd be missing the b. So I'm going to leave it like this, and I'm going to simplify as far as I can. I'm going to get x squared by itself. So I have x squared equals. If I take that 147 divided by 108, and I reduce that fraction, I get 49 over 36. Okay, to get rid of the square root, you take, or to get rid of the squared, you take the square root. And remember that results in a plus or minus answer. Square root of 49 is 7. Square root of 36 is 6. So there is what our x is. Alright. Number 10, use a graphing calculator to solve this equation. So here, I'm going to plug in the equation of y1. So 5x squared plus 6x minus 9, and I'm going to plug in 0 for y2. So now I can find their intersection points by doing second trace 5, and I'm going to move this cursor so to where it's around that first 0. Hit enter again, hit enter until it tells you intersection, and it says round to the nearest hundredth. So this one would be negative 2.07, 0. Okay, then we're going to repeat that process for this 0. So second trace 5. Go move your cursor to where it's around that 0. Hit enter until it says intersection. So this one would be 0.87, 0. So there are your 2 zeros using the graphing calculator. Alright, number 11. Simplify using imaginary I. So remember, square root of -1 is I. To simplify these, we're going to use perfect squares. So I'm going to try to find the biggest perfect square that goes into each of these numbers. So 4 doesn't go into it, 16 probably doesn't, 25 does, 25 and 7. And since 7 can't go any further, then that's the biggest one. Alright, square root of 25 is 5. Square root of 7 I can't do any with. That negative becomes the I. Okay, so let's move to this one. 84. The biggest perfect square that goes into that is 4 and 21. 21 breaks down to 7 and 3, and neither of those are perfect squares and can be broken down further. So this is 2, and then I still have this 2 outside. I'm going to have the I from the negative, 21. Okay, well if I multiply these together, I'm left with 4i square root of 21. Alright, on here, let's reduce this radical first. So the biggest perfect square that goes into this is 16 times 3. Square root of 16 is 4, so this becomes 4i because of the negative, square root of 3. Okay, now neither of these are like terms, so this is as far as you can go. Alright, on 14 and 15 we're simplifying. If you notice here, there is this subtraction sign, so that means I'm just combining like terms. So that negative distributes to both of those. So this becomes 2 minus 3 is -1, and negative 5 minus 4i is negative 9i. And that is in your a plus bi form, so you're done. Now this one, there's just 2 multiplied together, so we have to FOIL. So 2 times -1 is -2. 2 times 5i is 10i. 5i times -1 is -5i. And 5i times 5i is 25i squared. Okay, the thing you need to remember on this is that I squared is -1, so this becomes -25. So if I combine my like terms, -2 and -25 makes -27. And 10i minus 5i is positive 5i. So there is that answer. Alright, moving on. Solve each equation using the method of your choice. I'm probably not going to do all of these, but let's just go through on what you should do and when. So your test is multiple choice, and if you look at your answer choices and the answers are in the form of a simplified square root, then you should probably use the quadratic formula. If they are whole numbers, then you could probably factor. Okay? So you just need to look at your answer choices and base what you do off of that. Alright, so if we look at 16, this kind of is like this factoring one, where there is no b term. So if we take that, and I have 5x squared minus 11x equals 0. So if I move that 11x over, then I can factor out what they have in common. So they have an x in common. So this becomes x times 5x minus 11 equals 0. Then if we set both of those equal to 0, well, this one's done, and this one I would add 11 and divide by 5. So there are your zeros for number 16. Okay, let's see. Let me turn this over and we'll do some on the back. Okay, Number 17, I have 9x squared plus 16 equals 0. So this one, we need to do quadratic formula. There is no b, so what's your b is 0. So 0 plus or minus the square root of 0 squared minus 4 times 1, 9, because that's your a, times 16, all over 2 times 9. So this just becomes plus or minus square root. If I do 4, let's clear out of the graph, 4 times 9 times 16 will be 0 minus that, so negative 576 over 18. Okay, let's see if we can simplify that square root. It is 24. So this is plus or minus 24 over 18. Okay, and if I reduce that, I get plus or minus 4/3. And the negative, so that's I. Don't forget that part. Alright, and that's probably all I'm going to do on that part. Just to keep doing the same method. I will give you the quadratic formula on your during your test. Okay, these are matrices back at the beginning of the 6 weeks. So here, subtraction, you're just doing exactly what it says. So 6 minus negative 7 is 13. 5 minus 1 is 4. Negative 8 minus 2 is negative 10. Negative 2 minus 8 is negative 10. 3 minus negative 5 is 8. And 1 minus negative 8 is 9. So that's your resulting matrix, and you're done. Okay, on 25, if we set this up in a matrix, I'm going to take the coefficients are going to be one matrix. So 5, 2, 3, 3, 2, 2, negative 2, 2, 1. So don't forget the negatives if they're a minus. And then to find the x, y, and z, I'm going to take the inverse of that and multiply it by negative 4, 0, 1. So, second matrix, edit. It is a 3 by 3, so if we put this in, 5, 3, negative 2, 2, 2, 2, 3, 2, 1. Let's edit B. It's a 3 by 1. And then it's negative 4, 0, 1. Okay, so matrix, enter, negative 1, matrix B. So there are my answers. X, Y, Z is equal to 3, negative 5, 2. So those are your answers for each of those. Most likely I will be posting the answer key to these, so you will have the answers to the rest of 18 through 23, so you can check those. Alright, let me know, come see me in the morning if you have any questions, and good luck.